Welcome back, everyone. In the last couple of videos, we got an introduction to arrays, and we learned how strings are represented in the computer's memory as really an array of characters. In this video, I want to cover a couple important aspects of arrays and strings, and see some examples of what kind of problems we can solve with this new understanding of arrays, strings, and how they're represented in memory. First, I want to touch on a couple common areas of confusion when it comes to arrays. Let me bring back our example of just defining an array of 3 integers and storing some values at each of the locations. Now, it may seem strange to you that we're using 3 up here when we define this array, but then down here when we go to the locations of this array, we're using 0, 1, and 2 as the indexes. So just to clarify, up here when we define our array, inside these square brackets, we put the total number of elements that we want. We want 3 total elements. When we use this array, however, like on these last 3 lines, you don't use int again, just like you don't mention int again once a variable exists. You do still use the square brackets, but the number you put in these square brackets determines which location of the array you want to go. And again, arrays are 0 indexed, meaning that the first index of the array is scores bracket 0, the next is scores bracket 1, and the final is scores bracket 2, for a total of 3 locations. Another important aspect to understand is that we must provide a size to this array when we define it. I couldn't come up here and use int scores and not put anything in, like I could in some other programming languages. In C, we must tell the compiler the size of this array. There is one exception to this, however, which is a great segue into the next topic of static arrays. A static array is just an array that we already know what values we want to put in it. For example, if I know that I want to create an array called scores with these 3 particular scores, I could do this shorthand in one line like I proposed that we would see in a previous video. So I would use the similar syntax of int scores bracket 3, but then I can immediately assign some values to this array inside these curly brackets. And it turns out that when you define an array like this, a static array, you can leave out the value right here, because the compiler is able to figure out the size based on these 3 values. So this is just shorthand for the exact same thing. We're defining an array called scores, and then assigning the values 72, 69, and 89 to each location in this array respectively. It's also worth mentioning that once we define an array of a specific size, we cannot resize the array. For example, if we wanted to add a 4th value to this array by using a line of code like scores bracket 3 is equal to 33, then this is going to throw an error because this array is of size 3, not size 4. If we needed to add a new value to this array, we would have to either define a new array of size 4 and copy the first 3 values over along with the new value, or physically come in and change this array to support a 4th score. We'll see more on this in future videos, but I want to clear that up in case anybody was running into those kinds of issues. We then saw how we can pass arrays around as arguments to functions, and it's important to understand that in C, once you pass an array to a function, you cannot find out the size of the array. This is why you'll often see that when an array is passed as an argument to a function, a second argument of the array's size will be passed along with it. In part 2 on arrays, we learned that strings are just an array of characters. However, they have this special null character at the end so that the computer knows where the end of the string is. And it turns out that because of this, strings are a little special, and we do have the ability to find the length of a string, which is distinct from the length of an array. Again, we cannot find the length of an array. We can, however, find the length of a string by use of this null character at the end. So let's jump over to our Ubuntu virtual machine and let's see how we can write some code that will find the length of a string. I'll start by opening the terminal, and we'll change directory into tutorials and use code dot to open up VS Code in this directory. And I'll just maximize this. We're going to close out of this and create a new file. We're going to call this one length.c because I want to find the length of a string. And in this program, I want to first prompt the user for a string, like their name, for example, and then I want to run some kind of loop that will essentially count each letter in this string until we get to the null character and keep track of how many letters are in this string via some variable. So first let's do our boilerplate, and I'm going to include cs50.h because I want to have access to the getString function. We'll include standard.io.h so we can print stuff out to the screen. We'll do int main void, our curly brackets, and our return 0. And we're going to start by adding some comments in here. First, I want to prompt the user for a string. And then we want to find the length of the string. So we know that we can use the getString function to prompt the user for a string. And we'll just prompt them for a name. And of course, this is going to return a value. And if we want to do anything with that value, we need to store it in a variable. So I'll just call this one name. Okay, and now let's think about how we can find the length of this string. First, we're going to need a variable to keep track of how many letters are in this string. And to do that, I can do something like int length is equal to 0, just to start off counting at 0. And now I want to run a loop, but not a for loop because I don't know in advance how many times I want this loop to run. So how about I do this, which may look interesting, but we'll break this down in a second. While name bracket length does not equal \0 or this null character, and then inside these curly brackets I'll just increment length. And now outside of this loop we're going to print out with printf a %i and pass in length. So crazy syntax, but this is just putting all these concepts that we've learned thus far together. We're first defining a variable of type integer called length, and we're assigning it the value 0 because we generally start counting at 0. And then we're going to run this loop while name bracket length does not equal \0 or this null character. So what is this saying? Well, if name is just the name of the string that the user typed in, and a string is just an array of characters, then we can get to the first character in this string by using name and then square brackets. And what do we want to get at? Well, length on this first iteration of the loop is 0. So we want to get to the 0th, or really the first index in this string, which would be the first character of the string. And we're checking this condition. Is the first character in the string not equal to \0? Kind of strange syntax here as well, but we know that if this condition inside these parentheses evaluates to true, the loop will continue to run. But if it was false, then we would break out of this loop. So when we check this condition, is some character not equal to this null character? If we had the character h, for example, then the condition that we would be checking is h not equal to \0? And is this true? Well, yeah, it is. H does not equal \0. So what happens? Well, we run this code in our curly brackets, which increments the length variable, and then we check the condition again. This time we're going to be checking name bracket 1, since length is 1 at this point. And we check again, is some character equal to \0. And if we typed in the string hi, for example, we would now be checking I, and we would ask this question: is I not equal to \0? Which is true again, so we increment length to 2 and we recheck the condition. But this time we're checking name bracket 2, and we know that since strings are implemented as an array of characters with an extra byte at the end being this \0, then if the user typed in hi, then name bracket 2 is indeed a \0, and we would be checking, does \0 not equal \0? And that's a false statement, since \0 does equal \0. So we'll break out of this loop, and finally down here at the end, we're just going to print out this length variable. And I'll claim that this program will be able to figure out the length of any name, or really any string that the user types in. So let's come to our terminal, and we'll compile this with gcc-o length.c. And since we're using CS50, we have to remember to use -l CS50. And if I run this with /length and type in hi, we can see that we get 2. And minor aesthetic bug, I forgot to add a new line character down here. So I'll add that, save it, recompile, rerun, and now if I type hi, we get 2. And let's rerun this and type in hey, and we see that we get 3. How about Chris? And we get 5. So this is just to prove that strings are in fact an array of characters. However, they have this special \0 at the end to demarcate that the end of the string is right here. And because of this fact, we're able to find out the length of a string, which again is distinct from the length of an array. And we could design this program better and implement this functionality in a function. For example, maybe we want to create a function called string length that takes a string as input and returns an integer, being the length of that string. But it turns out that strings are so popular that there's a whole string library in C, which is part of the standard C library, and we can get access to these functions by including the string.h header file at the top of our file. So I can come to the top of my file and I can include string.h. And string.h is a library that has a bunch of string-related functions that we can use. And among these string-related functions is a function called strlen, strlen, short for string length, that takes a string as input and returns an integer, which is the length of the string. And if we want to use this function now in our code, I can come back in here, and instead of all of this, I can call this strlen function and pass in the name variable. And again, this function returns an integer, and if we want to do anything with that integer, we need to store it in a variable. So I can do the same thing. Int length is equal to strlen to define a variable called length that's going to store the return value of this function. And now if I save this, and I come recompile, rerun, type in hi, still works. If I type in hey, still works. And if I type in Chris, it still works. So this is how we would use the strlen function. And strlen is just one of the many functions in this string library. Another library that you might find helpful is ctype.h, which defines a bunch of functions related to C data types. And we'll look at some examples of functions in this library as well in future videos. But this is going to wrap it up for arrays for now. I hope you understand all these concepts that we've covered thus far. And if you have any questions, make sure you reach out via the comments or check out the new Discord server that's just been set up. In the next video, we're going to be introducing this concept of command line arguments. These commands that we can use in the terminal command line along with our program. When we compile our code, for example, we type the name of the compiler, which is GCC, followed by some command line arguments, such as this -o, to tell the program that we want to supply a name for the output file. And then we supply another argument of the name of the output file, and finally the name of the C file we want to compile, along with any other arguments like this -l CS50. And these extra arguments at the command line are what's known as command line arguments. And we'll see how we can implement this same functionality within our own C programs. So thank you all so much for watching. I hope you enjoyed. If you did, make sure to hit that like button so that I know you want to see more content like this in the future. And I look forward to connecting with you via Discord.